Vincent, hello.
Michael, we're back.
Awesome to be back with you. Yeah, this is almost the sequel to the last time you were on the show, so
Yeah,
it's going to be fun.
so SQL in this case, not the query language, like an actual SQL of events.
Yes.
Yeah, you can correct me if I'm wrong, but I think what happened is you had me on a podcast a while ago to talk about a course that I made, and like a big chunk of the course that we were very enthusiastic about was about this tool called Discash. And then we kind of came to the conclusion, well, we had to cap it off. Maybe it's fun to like do an episode on just Discash, since we're both like pretty huge fans of it.
Yeah.
I think that's how we got here.
I think that is how we got here as well, and we're going to dive into this. Honestly, it's a pretty simple library called Discache, but what it unlocks is really, really sweet. And we're going to talk about a lot of different angles. And now, even though it's just been not that long since you were on the show, maybe just give us a quick intro of who you are.
Sure. Hi, my name is Vincent. I've done a bunch of data machine learning stuff mainly in the past. That's sort of what a lot of people know me from. These days, though, I work for a company called Marimo. You might have heard from us. We make very modern Python notebooks. We took some lessons from Jupyter and we take a new spin of it. So that's my day-to-day. But I still like to write notebooks and do like kind of fun little benchmarks and also stuff with LLMs. And I've just noticed that for a lot of that work, boy, Discache is amazing. And I also use it for web stuff, and I think that's also what your use case is a little bit more of. But yeah, like in notebook land, you also like to have a very good caching mechanism. And on the Marimo side of things, we are also working on different caching mechanisms, which I might talk about in a bit. But just for me, the bread and butter, the thing that I've used for years at this point is DiskCache whenever it comes to like that territory.
Yeah, it's funny. This was recommended to me for Python Bytes as a news item over there quite a while ago, like years ago. And I'm like, oh, that's pretty interesting. And then I saw you using it in the LLM building blocks course, and it just unlocked for me like, oh my, oh, this is something else. And so since then I've been doing a bunch with it, and I'm a big fan. I've been on this, like, trying to avoid complexity, but still getting really cool responses, performance, et cetera, out of your apps. And I think this is a really nice way to add multi-process, super fast caching to your app without involving more servers and more stuff that's got to get connected and keep running and so on. But before we get into the details of that, let's just talk about caching in general. Like, what types of caching is there? I sort of gave a little precursor there, but yeah, dive into it.
So, like in the course, the main example that I remember talking about was the one you've got this LLM, and you want to do some benchmarks. And it might be the case that, I don't know, using an LLM for, let's say, classification, like some text goes in, we got to know whether or not it's about a certain topic, yes, no, or something like that. Then it would be really great if, suppose the same text came by for whatever reason, that we don't run the query on the LLM again. It's like wasted compute, wasted money. So it'd be kind of nice if the same text goes in, that would then say, oh, we know what the answer to that thing is already. We cached it, so here you can go back. And that's the case when you're dealing with like heavy compute ML systems. But there's a similar situation that you might have, I guess, with expensive SQL queries, or you want to reduce the load on a database somewhere. Then having some sort of a caching layer that's able to say, oh, you're querying for something, but I already know what it is. Boom, we can send it back. I think the classical thing you would do in Python is you have this decorator in functools, I think, right? The LRU underscore cache.
Yeah, exactly.
That's the hello world to that. But the downside of that thing is that it's all in memory. So if you were to reboot your Python process, you lose all that caching. So that's why people historically, I think, resorted to, I think Redis, I think, is the most well-known caching tool. It's the one I've always used. There's Memcache, I think. There's other tools. You can use Postgres for some of this stuff as well. But recently, especially because disks are just getting quicker and quicker, people have been looking at SQLite for this sort of a thing as well. So that's, I think, the quickest summary and also sort of the entryway to how I got started with Discache.
Yeah, and so for this example that you highlight in the LLM building blocks course, it's not a conversation. It's like a one-shot situation, right? You come up, you say, I have some code or some documents, and I have almost like an API. I'm going to send that off to the LLM and ask it, tell me X, Y, and Z about it. And sure, it's got some kind of temperature, and it won't always give an exactly the same answer, but you're willing to, you're willing to accept an answer. And at that point, like, why ask it again and again and again, which it might take seconds, it might cost money. Whereas if you just remember through caching somehow, you remember it, it's like, boom, instant.
Yeah, and it tends to come up a lot in when you're doing benchmarks, for example. So you have this for loop, you want to go over your entire data set, try all these different approaches. And if you've got a new approach, then you want that to run, of course. But if you accidentally trigger an old approach, then you don't want to incur the cost of like going through all those different LLMs. I should say, like, even if you just forget about LLMs, let's just say machine learning in general. Let's say there's some sort of image classification thing you're using in the cloud. There also, you would say, like, file name goes in, that's an image, and if the same file name goes in, we don't want the expensive compute cost to happen either. So it's definitely more general than LLMs, but LLMs do feel like it's the zeitgeisty thing to worry about.
Yeah, I think for two reasons. One, because they're just the topic du jour, and two, because they're I think a part of computing that most people experience that is way slower than they're used to.
Yeah, well, and especially if you're, if I suppose that you have an attic somewhere and you're a dad and you want to do home lab stuff and you're playing with all these open source LLM models, then you also learn that yeah, they're fun to play with, but they also take a lot of time to compute things. So then immediately you get the motivation to do it the right way.
Yeah, I built a couple little utilities that talk to a local LLM. I think it's the OpenAI open weights one, that 20 billion parameter one I have running on my Mac Mini, and it's pretty good, a little bit slow, but it's fine for what it's being used for. And I use your DiskCache technique on it, and if I ask it the same question again, it's like, boom, yeah, you don't need to wait 10 seconds. Here's the answer.
Yeah. So that, and I guess from your perspective, I think your main entry point to this domain was a little bit more from the web dev perspective, right? Like and I suppose you're using it a lot for preventing expensive queries to go to Postgres, or I don't exactly know your backend.
But you won't believe how optimized my website is. There's not a single query that goes to Postgres because they go to MongoDB. I'm just kidding.
There you go.
So no, but your point is totally valid. Going to the database, right? Now, I don't actually cache that many requests. I don't avoid that many requests going to the database. They're really quite quick, and so I'm okay with that. But when you think about a feature-rich database, feature-rich web app, there's just tons of these little edge cases. You're like, oh, we got to do that thing. And it's not a big deal, but we got to do it 500 times in a request. Then it is kind of a thing. So let me give you an example. I'll give you some examples. So, for example, the good portions of the show notes on talkpython.fm are in Markdown. I don't want to show people Markdown. I want to show them HTML, right?
Oh, yeah.
So when a request comes in, it'll say any fragment of HTML that needs to be turned into Markdown, instead of just going, well, let me process that. It just goes, all right, what is the hash of this? Or some other indicator of the content. And then I've already computed that and stored it in Discash. So here's the HTML result. Another example is there's a little YouTube icon on each page, and that's actually in the show notes, but then the website parses the YouTube ID out and then embeds it with there's a bunch of stuff going on there to like keep YouTube out of spying on my visitors. But stuff happens. YouTube ID is used. That could be parsed every time. Or I can just say, this episode has this YouTube ID. That information goes into a cache, right? And because it's Discache, it's a Discache sort of scenario, like a file-based one, not an LRU cache. It doesn't change the memory footprint, and it's shared across processes. So in like the web world, it's really common to have a web garden where you've got like 2 or 4 processes all being like round robin from some web server manager thing, right? If you don't somehow out of process that, either Redis or SQLite or database or something, then all of those things are recreating that, right? They can't reuse that, right? So there's a lot of interesting components there.
I suppose your web deployment, you have like a big VM, I suppose, and then there's like multiple
Yeah.
Docker containers running, but they do all have access to the same volume, and that's how you access SQLite. That's
Bingo. Yeah, exactly. And how am I doing? I believe, yeah. So what I have done is in the Docker Compose file, I have an external, this is also important for Docker. So I have an external folder on a big hard drive in the big VM that says, here's where all the caches go. And then depending on which app, it'll pick like a subdirectory it can go look at or whatever that it's using. And so that way, even if I do a complete rebuild of the Docker image, it still retains its cache from version to version and all that kind of business. You could do that with a persistent VM as well, volume as well. But I've just decided, you can go and inspect it a little easier and see how big the cache is and stuff like that.
Because so we're gonna get into the weeds of how Discash works exactly, but I'm triggered here because it sounds like you've done something clever there. Because what you can do in Discash is you can say, look, here's a file that's SQLite, and then it behaves like a dictionary but it's persisted on disk. But what I just heard you say is that you've got multiple caches. So am I right to hear that for like some things that need to be cached, let's say the YouTube things, that's a separate file, and then all the markdown stuff, that's also a separate file, and therefore if connections need to be made to either, that's also kind of nicely split. Is that also the design there?
Yeah, that is. And actually, before, we're going to dive into all the detail of how it works, but I'll just go, to give people a little glimpse, I'll go ahead and show, I've got this whole admin back in here, and I've got different caches for different purposes. Because they're just SQLite files, you can either say, give me the same one, or you can say, this one is named something else, and it has a different file name or different folder or whatever. Right, so I've got one that stores things like that YouTube ID I talked about, and any markdown, any fragment of markdown anywhere in the web app that it needs to say that needs to go to HTML,
and it's like 8,000 items in that thing.
Yeah, in this one there's 8,970 items, which is 9 megs. Right, I mean it's not huge, but it's not too bad, and you can actually even see where it thinks it lives, but that's not really where it lives because there's the volume redirects and stuff. But I've also got stuff for directly about the episodes that it needs to pull back. And then I do a lot of HTTP caching. And one of the things that I think is really wrong with web development is people say, well, that's like a stale image, or that's a stale CSS file, or JavaScript, all that kind of stuff. So if you just do like super minor tricks and just put some kind of hash ID on the end of your content, it will, and you teach your CDN or whatever that's a different file if it varies by query string, then you never ever have to worry about stale content ever, right? But computing that can be expensive, especially for remote stuff. Like if it's on it's like a S3 thing, but you still want to have it do that. So I have a special cache for that, and that's like pretty complicated to build up because it's got to do like it's almost 700 web requests to figure out what those are. But once they're done, it's blazing fast. You don't have to do it again, right? Unless it changes, then it doesn't change much, and so on. So that's the way that I'm sort of using and appreciating Discache.
Yeah, well, it works well in your setup because you've gone for the VM route. I mean, if you go for something like Fly.io or maybe even DigitalOcean has like a really, I think it's a nice like app service, but that all revolves around Docker containers that like spin up horizontally, and I don't think those containers can be configured in such a way that they share the volume. So in that sense, you could still use Discache, but then each individual instance of the Docker container would have its own cache, which still could work out. Not going to be as well functional if it's going to be better with your setup though.
Yeah, absolutely. I agree though. You could still do it, or you could go. I'll take the zen of what Vincent and Michael are saying today, and I'll apply that to Postgres, or I'll apply that to whatever data. You could pull this off in a database. You would just have to do more work.
Yeah, I mean, I've had a couple of, I think it was like a Django conference talk I saw a while ago. They also like raving about Discache, but so like the merits of Discache do depend a little bit on your deployment, though. That is, I think, one observation. Like in your setup, I can definitely imagine.
Interesting.
Sweet. Yeah.
Yeah. All right. Well, I don't even think we properly introduced this thing yet. So
let's maybe go there. Yeah.
Let's start there. Let's start there.
It's time. Okay.
It's time.
Yeah. I guess like the simplest way I usually describe it, it really behaves like a dictionary, except you persist the disk, and under the hood is using SQLite. I think that's the It doesn't cover everything, but you get quite close, if that's the way.
Yeah. I think there might be, I keep harping on this on the show, but there are so many people that are new to Python and programming these days. Many of that, almost half of them. I think it's worth pointing out, just like, what is SQLite? Like, why is it different than any other database? Like, why have I been using the word database or SQLite when SQLite is a database, right? That's weird.
So I never really took a good databases course, so I might be ruining the formalism of it. But the main, like, for me at least, the way I like to think about it is Postgres. That's a thing I can run on a VM, and then other Docker containers can connect to it because it's running out of process. There's some other process that has the database somewhere, and I can connect to it. And I think the main thing that makes SQLite different is that, no, you got to run it on the same machine, on the same process where your program is running. And that's, I think, the main. And there's all sorts of little details like how the data structures are used internally, and like SQLite doesn't have a lot of types. There's lots of other differences. I think that's the main one. Unless, Michael, I forgot something.
Yeah, no, I think operationally, it's a separate thing that you have to run. It has to have both. It has to be secure, because if your data gets
we're talking about so for Postgres. This is not for SQLite.
Yes,
per se, but
for Postgres.
Yes, it's running somewhere. People can SSH in if you're not careful. You got to be mindful of passwords and all that stuff. That's totally true.
Right, and it could go down. Like, it could just become unavailable because you screwed up something, or whatever. Right, it's a thing you have to manage, and the complexity of running your app. When it's like, well, it used to just be one thing I could run in a Docker container. Well, now I got different servers. I got to coordinate, and there's firewalls, and there's like. It just takes it so much higher in terms of complexity that, like, SQLite is a file.
Yes.
You know what
I mean, I do want to maybe defend Postgres a little bit there, because one thing that's like really nice and convenient in terms of like CI/CD and deployments and all that. Suppose you want to scale horizontally, and there's like Docker containers running on the left, and there's this one Postgres thing running on the right. I mean, you can just turn on and off all those Docker containers as you see fit. They're just going to connect to the Postgres instance. And, I've done this trick for Calm Code a bunch of times where I just switch cloud providers because Postgres is running there. And I can just move the Docker containers to another cloud provider, and, it all works fine. No migration necessary. With SQLite, that aspect is a little bit more tricky. You have to be a bit more mindful. Although, I should mention, it might be worth a Google. There's actually this one new cloud provider that's like very much Python focused. It's called Plash, PLA.sh, I think.
Oh, this is new to me.
Yeah. So
okay. Look at this.
Yeah, so
from .py to .com in seconds.
Yeah, it's the Answer AI, Jeremy Howard and friends. I don't know to what extent this is like super production ready. And SQLite, you got to be mindful of the production aspect for some reasons as well. But one thing that is kind of cool about them is they give you a persistent SQLite as a database and a Python process that can just kind of attach to it. And they just, in their mind, that's the simplest way that a cloud provider should be. They take a very opinionated approach. So yeah, if you're interested in maybe running this as a web service, like migrations are a little bit tricky in that realm because you do have to like download the entire data set, do the migration, and upload it again, I think, if I recall correctly.
And for some apps, that's no big deal. Others, that's a mega deal. Depends how big that database is, right?
So I'm not suggesting this is going to be for everything and everyone, but I do think it's cool, which is why I figured I'd mention it. So that's
it's news to me. I'm going to follow up with Lightstream.io. Have you seen this?
Yeah, no, that is also really neat. So basically, what if you want to back up your SQLite? Like, how could you do that? It might be nice to do that with S3. And it's I think it's like the guy who made the thing works at Fly.io. He's doing a bunch of low-level stuff. One thing about that open source package is also really interesting, by the way, is I think he refuses PRs from the outside. Like, he just wants to have no distractions whatsoever. Like, he has a very interesting way of developing software. You can submit issues, of course. Like, I think if you scroll down, there used to be a notice that basically said, "Hey, this is I'm not running this as your average." Yeah, there you go. We welcome contribution guide. We welcome bug reports. But yeah, this is a way where you can basically stream updates to S3, and the main observation there is S3 is actually really cheap if all you do is push stuff into it. If you never pull it out, like usually getting it out is the expensive bit of S3. Yeah. So this is like pennies on the dollar for a really decent backup. And you can also send it to like multiple. You can send it to Amazon and also to DigitalOcean if you like.
Yeah, because these days S3 is really a synonym for blob storage on almost any hosting platform, right? Like it used to be S3 meant go to literally S3 at AWS, but now it's like, or DigitalOcean object store, spaces, or to, you name it, right? They've all adopted the API, kind of like OpenAI's API and LLMs.
Yeah, I will say it's a little bit awkward that you have to like sometimes you go to a cloud provider and they say you have to download a SDK from a competing cloud provider and then you can connect to our cloud bucket.
I know, and it's usually Bodo 3, and Bodo 3 it's if you want to cry because you're using a library, like Bodo 3 has a good chance of being the first one to make you do it. It is so bad.
It's
Not custom. It's not built with craft and love. It's like auto-generated where you pass these, like you pass this kind of dictionary and then the other argument takes a separate dictionary that relates back. It's just like, could you give me a real API here?
I mean, the one thing I can appreciate about Bodo that I do think is honest to mention is like they do try to just maintain it, like the backward compatibility of that thing also means it can't move in any direction as well. And there is this meme where Google kills all of its products way too early, and Amazon's meme is that they kill them way too late, sometimes never, right? And so in that sense, I can appreciate that they just try to keep Bodo just not necessarily as user-friendly, but they do keep it super stable. Like I get there's a balance there.
Yeah. I feel like we still haven't really introduced Discache. We kind of set the stage.
anyway, but yeah, SQLite, super cool. How does it work under the hood? Well, it's really just like a Python dictionary. So you can say something like, hey, make a new cache. And then you can do things like cache, square bracket, string name, equals, and then whatever Python object you like can go in. And Python has this serialization method called a pickle. Serialization just means, well, you can persist it to disk in some way, and then you can sort of get it back into memory again. And that's what Discache just uses under the hood. So in theory, any Python object that you can think of can go into DiskCache. The only sort of thing to be mindful of is if you have like Python version, if NumPy version 1 in Python 3.6, and you're going to inject a whole lot of that into Discache, don't expect those objects to serialize nicely back if you're using Python 3.12 and NumPy version 2 or something like that.
Right, because pickle is almost an in-memory representation
Yes.
of the thing, and that may have evolved over time. That's also a true statement about your own classes, potentially.
Yeah, so if you're dealing with multiple Python versions and multiple versions of different packages, there's like a little bit of a danger zone to be aware of there. That said, for most of the stuff that I do, that's basically a non-issue. But I do get this nice little object that can just store stuff into SQLite and can get it out, and it's very general. It's going to try to be clever about it. Like if you give it an int, it's going to actually store it as an int and not use the pickle format. So there's a couple of clever things that it can do. And it's also really like a Python dictionary. So you can do the square bracket thing. You can also do the delete and then cache square bracket thing to delete a key from the cache. Just like a Python dictionary, you have the get method. So you can say .get key, and if it's missing, you can pass a default value. So it's very much like a dictionary. I think Bob's your uncle on that one, unless Michael, I've forgotten something, but I think that's the simplest way.
Yeah, pretty much. Yeah, I think so. The difference being it's not in memory; it's stored to a file. Happens. It's not always a SQLite file, but often it is a SQLite file as its core foundation that it's stored to. So it gives you, process restart ability where it still remembers the stuff you cached. It's not like LRU cache. We got to redo it every single time. And I don't know where it is in the docs here, but the thread safety bit of it and the cross-process safety is really nice about, is it persistent? I've got this whole table here, things like, is it persistent? Yes. Is it thread safe? Yes. Is it process safe? Yes. Compared against other things like people might choose. And that, honestly, I think that is the other half of the magic.
So especially for your web stuff, I would say that's the thing you really want. And some of that, of course, is just SQLite itself. Historically, one reason why people always used to say use Postgres, not SQLite, has to do with precisely this concurrency stuff. My impression is that SQLite is really good at reading, but writing can be slow if multiple processes do it. Some of that, I think, is related to the disk as well. I don't know to what extent that has changed, but historically, at least, whenever I was doing Django, hanging out at Django events, people are always saying, just use Postgres because it's better for the web thing. But it is safe. The SQLite might become slower, but it is thread safe if a problem.
There's they've thought a lot about in this thing about transactions, concurrency, and basically dealing with that. But it is ultimately, for the most part, still SQLite underneath. But, the thing with a cache is if you're writing it more than you're reading it, you probably shouldn't have a cache.
Yeah,
You know what I mean?
That beats the purpose.
Exactly. Like you get no value if you're recreating it. You're only probably just doing overhead and wasting memory or disk space. So it's inherently a situation where it's going to be pretty read heavy, and SQLite is good at read heavy scenarios.
And maybe it's also fair to say, like the LRU cache that you get with basic Python. So also to maybe explain that one. So the LRU cache is a little bit different because you decorate a function with it, and then given the same inputs, one output goes out. You can kind of keep track of a dictionary that's in memory. If you don't have a lot of stuff to keep in the back of your mind, then maybe you don't have to write to disk, right? So there's also maybe a reason to just stick to caching mechanisms that use Python memory, because I also think I would imagine it to be quicker too. But that maybe that's also,
yes.
That should be quicker. It's just that if you're capped at memory, then you might want to spill to disk, and then DiskCache becomes interesting too.
Right. For example, you have literally zero serialization, deserialization. Right. What you put in LRU cache is the pointer to the object that you're caching. Right. If you've got like a class or a list that's like part of the LRU cache.
The one thing that is good to mention that's also like a really nice feature of DiskCache is just like LRU cache has a decorator, so you can decorate a function. DiskCache also has that, and it works kind of interestingly too. So when you decorate the function, you do have to be a little bit careful if you use that, but then DiskCache will, I think it will hash the function name and the inputs that you pass. I don't know if it also hashes the contents of the function. Like if you change the function itself, I don't know if DiskCache will actually put that in a different slot, if that makes sense.
Yeah, you can say at cache memoize, which is the design pattern speak for just remember this.
Yeah,
it takes the arguments.
And then it has like the Fibonacci sequence, which is the classic example, of course. And like there are some extra things you can set there as well. So you can say things like, hey, I think you're able to, you're able to set the expiry. So you can say things like, I want to cache this, but only for the next 5 minutes or so, which can make a lot of sense if you're doing like a front page kind of a thing. So like the Reddit front page or something like that updates, but not every second. That probably updates like once every 5 minutes or something like that. And then you do want to have something that's cached, but then after that, you want the cache to basically just reset. And that is something you can also control with a few parameters here.
Right. That's interesting. There's a couple of good use cases that come to mind for me. Like one, if I put this on the function that generated the RSS feed for Talk Python, I could just say every 1 minute, and then it might be a little bit expensive to compute because it's got to parse, 535 episodes or whatever. But then for 1 minute, all the subsequent requests, just here's the answer. And then without me managing anything, it will just automatically the next minute refresh itself by the nature of how it works, right?
How much traffic do you get on that endpoint, just roughly?
1 terabyte of RSS a month.
Okay, gotcha. Okay, but there you go. Like then, just doing that like once a minute instead of like many times a minute will be a huge cookie. Yeah.
I would say it's probably more than one request a second, and the file size, the response size of the RSS feed is over a meg, and so it's a non-trivial amount of asking.
Yeah. And then and how do you fix that with a whole bunch of infrastructure? No, with a decorator. Like that.
Exactly. Yes, exactly. You pretty much summed up all the reasons why I'm so excited about this, because it's like you could do all of this complex stuff, or just like you could just literally, in such a simple way, just not recompute it as often.
Yeah.
And here's the danger. What if there's a race condition, and oh my goodness, 2 of them sneak in? You know what I mean? Like, okay, so you've done a little bit extra work and you throw it away. Who cares?
I want to use Redis now, and Redis is cool, but I've never used it before. Better buy a book. Okay, no. With DiskCache, if you, I mean, I'm sure it won't solve everything, but I make a bit of a joke by saying just use a decorator, but it's honestly that feeling that this library really does give you.
Yeah.
You can just use it as a decorator, which has a lot of great use cases. You can just use it as a dictionary, so it still feels like you're writing Python. It's just Python with one concern less, and that is the magic.
Yeah. And it takes on so many of the cool aspects of these high-end servers like Postgres or Redis or Valkey. Valkey's sort of the shiny new Redis, right?
I would actually love to do a Redis benchmark. I haven't done that yet, but one thing I do wonder with disks are getting so much faster.
Yes.
Right. And so you can actually at some point wonder, like, how much faster is Redis really going to be, and how much money are you willing to spend on it? Because if your cache is huge and it all has to go in memory in Redis, I could be wrong, but Redis is fully in memory, I think, right?
I believe so. There is the database aspect. Redis is weird because it could be so many.
Redis is cool. It can do a lot.
Yeah.
But
They actually have benchmarks here on.
There you go.
Compared against Memcached and Memcached and Redis, and it has the get speed and the write speed. And this is smaller is better. Yeah, look at this. Discash beats Redis.
And is that because of and I imagine that's because of the network hop or something?
Yeah, exactly. I bet it's the network connection.
Okay, so if you're running it on the same machine, you would have a different number there. Might be good to maybe caveat that.
Yeah, it might be.
I mean, but also that I think that I don't know when they ran this benchmark, but they probably I just checked on PyPI. This project started in 2016, so it might.
I bet this is 2016 data right here. If I know how these docs go.
Yeah. So like it could also be that those are old disks comparing old memories, right? So then this is one of those weird benchmarks. You got to really run them every 6 months or so for them to remain relevant.
Yeah. Yeah. I mean, the new NVM, VVM, whatever, disks, SSD disks are so fast.
Well, and also, they're not memory, and memory is expensive nowadays.
Yes, it is.
People want to build data centers with them, I've heard.
Yeah. And on the cloud, this is another really interesting aspect to discuss, probably more of a web dev side of things, but if you do LRU caches or even to a bigger degree, I run a whole separate server, even if it is just a Docker container that holds a bunch of this stuff in memory. That's going to take more memory on your VM or your cloud deployment or whatever. And if you just say, well, I have this 160 gig hard drive that's an NVVM high-speed drive, like maybe I could just put a bunch of stuff there. And you can really thin down your deployments, not just because it's not in memory in a cache somewhere, but if you're not having any form of cache, you might be able to dramatically lower how much compute you need and avoid the memory, right? Like there's layers of how this could like shave off.
And again, it's one of those things of like, oh, I just, can I pay for disk instead? Oh, that's a whole lot cheaper. What else do I got to do? You just got to write a decorator.
Yeah, I think I pay $5 for, I think I remember exactly, but I pay something like $5 for 400 gigs of disk.
There you go.
Do you know how much 400 gigs of RAM will cost in the cloud?
Well, I mean,
more.
There
More
goes
than five.
There goes the college tuition. But
exactly. Sorry, kids.
Yeah. No, but like it's and again, like I vividly remember when I started college, people were always saying, "Oh, keep it in memory because it's way faster than disk." But I think we got to let a lot of that stuff just go.
Interesting idea. Yeah, I agree though. I think you're right.
But anyway, like, but so far, we've mainly been discussing like the mechanics of it. But there's some bells and whistles. I think we should maybe also mention like the expiry definitely is one of them. There's also like first in, first out kinds of things that you can do.
Yeah.
So maybe if we could go back.
There's a bunch of features actually there. Like, I think the expiry is interesting already. Because if you do regular, say like LRU caching or something like that, you have a natural. It's going to go away when the process restarts, and that's going to happen eventually. Even in a web app, you ship a new version, you got to restart the thing or something. But like when it goes to the disk, it starts to pile up, right? That's why I have this little admin page that has like, how big is this, and a button to clear it.
In fairness, that can blow up to a lot of Palooza as well if you're not careful. It is a concern.
Yeah, it is definitely a concern. And so I think a big way to fix it, like the expiry, we already talked about why it's interesting for like stale data. You want it to just like auto refresh, but it's also just a safeguard of, maybe we'll just recompute this once a month. It's really quick and easy. It's only maybe just don't let it linger forever.
I think what you can also do, though, if I'm not mistaken, is I think you can also set like a max key size. So you can say this particular disk cache can only have 10,000 keys in it, and use a first in, first out kind of a principle.
Right, or last accessed, or number of times. There's a bunch of metrics there actually for how that works. Yeah, it's pretty interesting.
I've never had to like fiddle around with them too much, but it's one of those things where even if I don't need it right now, it is just a relief to see that the feature is there in case you might need it later.
Yeah. Yeah, for sure. Let me see if I can find out where that is. I don't know. Keep bouncing around the same spot. I've got it less. We can just talk through them. So I think the tags and expiries are pretty interesting. But then there's also, I think, something that surprised me a little bit is these different kinds of caches. So there's like a fan out cache. Have you looked at these any? These are interesting.
I remember reading about. I've never used them, but I do remember reading them.
So let me give you the quick rundown, and then you'll understand instantly. It's super quick. So it uses sharding, which is a database term, right?
Mm-hmm.
So sharding is like if I've got a billion records, and it's a challenge to put them all in the same database entry, a database table or server. I could actually have 10 servers and decide, well, okay, what we're going to do is if it's a number of the ID of the user. If the first number is 1, then they go into this database. If it's 2, then they go in that, right? So 2005 goes into the second database and so on. So it does that as well. This is one of the things it does to try to avoid the issues of multiple writers, I believe. So you're less likely to write to the same database, so it doesn't have to lock as hard.
It's kind of what you do, where you say, "Oh, I've got this for the YouTube link, and I've got this for the HTML Markdown." Except those are like those are like different chunks because of their use case. But you can also imagine, well, I've got this long list of users, but I still want to benefit from having multiple SQLite instances, and that I suppose that's when you use this, right?
Yeah, I think that is why. So it says it's built on top of cache, DiskCache fan out, automatically shards. Automatically, you just said how many you want. It figures out what that means. And it says, while readers and writers don't block each other, writers block other writers. Therefore, the shard, a shard for every concurrent writer is suggested. This will depend on your scenario. Default is 8. So that's pretty cool.
Yeah, okay. And presumably internally it does something like hashing to figure out how to send it around the shards.
Right. The keys themselves have to be hashable anyway, probably. So it just hashes the key and then shards on like the first couple letters or whatever. Yeah, this is cool. So it avoids the concurrency crashes. The one difference for me, the reason I didn't choose fan out cache is because I want to be able to say, I want to clear all the YouTube IDs, but I want to keep the really expensive to compute hashes of the remote. Like I want to be able to clear stuff if I really have to by category. And I guess you could also do that with tags, but I'm just not that advanced.
Well, and also keep it simple, right? Like, again, it's one of those things where it's nice to know that this is in here, even if you don't use it directly. I do agree. This is a really nice feature.
It is, and I probably will never in my life use it, but it's really cool that it's like, it's one of those things about a library that when you're thinking about picking it, it's like, okay, the core feature is great, but if I outgrow it, what is my next step? Do I have to completely switch to like something really different like Redis or Valkey, or do I just change the class I'm using?
I had that with this. So I actually had that feeling a while ago. We're going to get to my example, I think, a bit later, but I was using the Memwise decorator to like decorate a function to sort of properly cache that. But the one issue I had is an input to that function was a progress bar. That's kind of a Remo specific thing. I wanted this one progress bar to update from inside of this one function. But the downside was that every time I rerun the notebook, I make a new progress bar object. Oh, and that means that the input has a different object going in.
Right, so you never actually hit the cache.
So, oh my God, I'm never hitting the cache. This is horrible. Then it turns out the Memwise decorator also allows you to ignore a couple of the inputs of the function. So you can
interesting, like ignore by keyword or something, keyword argument.
Precisely, and there's a bunch of use cases for it, and this was one. And you can just imagine my relief after writing the entire notebook to then look at the docs and go, oh, sweet, solved.
Yeah, that's super sweet, yeah. Okay. I think there's right below this. There's a couple. We can just go down this list here. There's some cool
Django cache.
So they have a legit Django cache.
Yeah.
Straight in.
Sweet. Yeah, I remember. I recall that it was like a huge Django following for this thing.
Yeah, and I think this is part why. And when I first saw it, the reason it got sent to me, somebody's like, "Oh, this DiskCache Django cache is a really cool thing to just drop into Django," and I'm like, "That's cool." I'm not using Django, but I admire it. That's why I didn't really look into it until I saw your use case outside of Django. I'm like, oh, okay, I understand how much this can do. So the Django DiskCache says it uses the fan-out cache, which we just discussed with the sharding, to provide a Django-compatible cache interface. And you just do that in your settings file, and you just say the backend is diskcache.django cache, and you give it a location. Boom, off it goes, right? So really, really nice.
Cool.
Yeah, and it sounds like you've done more Django than me.
I mean,
how's this sit with you?
I mean, To be very clear, I do think Django is really nice and really mature. I do sometimes have a bit of a love-hate relationship with it because Django can go really, really deep, and some of the configuration stuff definitely can be a little bit in your face. So the main thing I just want to observe is doing everything manually inside of Django can be very time consuming. So it's definitely nice to know that someone took the effort to make like a proper Django plugin in the way that Django wants it. That's definitely the things I appreciate here. What I don't like, I've never really used this in a Django app, to be honest.
Yeah, it has a lot of nice settings here. Like you can set the number of shards, the timeout. So in case there's a write or read contention, it can deal with that, or it can at least let you know you're failing.
Yeah,
it even has a size limit.
Does it say how you can configure what to cache and whatnot, or is like I've never really used caches in Django in general, so I don't know if there's like a general cache feature in Django itself that it will just plug into, or if you still
I think there is a general cache feature in Django. The Django people are like screaming silently.
Yeah,
I apologize. Sorry. I know, but I'm pretty sure it's just a built-in Django cache functionality.
Exactly.
And then it just routes into this thing.
Exactly. So instead of configuring Redis, you just feed it this, and you're good. That's the idea then.
Yes, exactly. So there's more. The next one, I have got to rage against the machine. I'm sure it's the way, but DQ, pronounced deck.
Yeah.
So I don't know. For me, I still say DQ. I don't say deck. Like it's spelled DEQUE, and I know a lot of computer science people just call that deck. But Discache.DQ or deck, however you want to use it, it provides. There's a couple of higher order data structures that like operate on what we talked about so far, but to give you data structure behavior, right? Like what we talked about so far is sort of dictionary, but not list or order or any of that. But this you can actually do go and add a thing. How do we add one? Anyway, you can say like pop left over and over to get. I guess you just add it like
it's kind of like a queue.
Like a queue, exactly.
Yeah.
With the goal of taking stuff out of it instead of into it, right? But you don't normally think of a cache as doing that. But it'd be a cool way actually to fan out work across processes.
I was about to say like that's a really good. I think. I mean, there's people that have made I forget the name. What's the Python queuing system? Celery.
Yes.
So that one is also built in such a way that you can say like, oh, where do you have like the list of jobs that still need doing? And I think also Redis is used.
Yeah, right. Redis MQ. Yeah, exactly. Or Rabbit MQ as well.
Exactly. But you can configure SQLite if you want to, though, if I recall with those. It's just that in this particular case, if you don't want to use Celery, you can still kind of roll your own by using Discash as well. I'm assuming it uses the same pickle trick, so you can do general Python things, and if the process breaks for whatever reason, you still have the jobs that need doing.
Yeah. We're still gonna have to talk about this serialization thing. These pickles.
Yes,
but not yet. Let's go through this. Let's go through the list first.
The list first
before we get distracted, because it's a deep. So deck. I guess we'll go deck. Deck provides an efficient and safe means for cross-thread, cross-process communication. Like you would never think you would get that out of a cache, really, but it's.
I see how it's SQLite.
Yeah, exactly. But you would do work to do that, right? You would do like transactions, and you would do sorting. You would figure out, well, what if there's contention? I mean, the fact that it's just kind of a pop, it's pretty nice.
Yeah, that's definitely nice. No, that's definitely true. Although one thing that makes it easy in this case, though, is again. It is all running in like one process. So it's not like we've got SQLite running in one place and there's 16 Docker containers that can randomly interact with it.
That can, though.
Is that the case?
Because Discache itself is already cross-process safe. Like that's why I was so excited about it for the web.
Sure, but it has to be on the same machine, though. Like I do think.
Yes, it's got to at least be accessible. Rush, right? That is true. Because technically, there's nothing that says you can't put the file anywhere. I think there's mega performance issues and locking issues on. It says basically don't use it on network drives.
Yeah, exactly. So that's the thing. Like some of this is like you can do the locking, you can do all those things, you can do it well, but the practicality of the network overhead is something that usually causes a lot of kerfuffle. At least in my experience.
Yeah. Okay. Another one is Discache Index, which creates a mutable mapping and ordered dictionary. So if you kind of really want to lay into the dictionary side, you can do that. That one's transactions as well. So you can actually, it has like sort of in-place updates and other things you can do. So you can say, I want to make sure that I'm going to get two different things out of the cache. And I want to make sure that they're not changed while I'm doing that, right? Just like you would with threading or something.
Yeah, so
And that's pretty
nothing
neat.
can happen in between. So they both have to come out at the same time. So the two values that I get, they both existed at the same time in the cache at the point in time that I was retrieving it.
Yeah, exactly. So with cache.transact, and you just go to town on it. That's pretty straightforward, right?
Yeah.
Is there any more in here? There's a bunch of recipes for like barriers and throttling and probably semaphore-like stuff, but I don't really want to. I don't want to talk about. But you touched on these eviction policies. Here's where I was looking for. There's these different ones here that are kind of cool. Whoops, don't mean to go away.
Yeah. So when do you? So you can set a maximum to the cache. I think you do that by number of items typically in it. Could also be the case.
Key size or something. Yeah.
Yeah, or like total disk size. Maybe we should double check actually. Maybe
the default for the disk size is 1 gig.
Yeah, there you go.
So there's already a built-in one, yeah, which
okay.
might catch people off guard. Like, what? Much of the stuff is cached, but not always. I don't understand. Like, oh,
yeah, you got to be a little bit mindful of that, I suppose. But it's a saying default not to have it go to infinity. Let's put it that way.
Agreed. Agreed.
But yeah, I guess it's a small screen on my side, but like, yeah, last recently stored.
I'll read them out. I'll read them out for you. Yeah. So we got last recently stored as a default. Every cache item records the time it was stored in the cache, and that adds an index to that field, so it's nice and fast, which is cool. There's some other ones that are more nuanced, like least recently used. So not in terms of time, but we've got one that was accessed 100 times and one that was accessed 2 times. Even if the one that was accessed 2 times was just accessed, that one's getting kicked out because it's not as useful. I don't know. That's a pretty neat feature. And then the one people would expect is, I don't know, maybe least recently used. LRU.
Yeah. Exactly. So there's also pruning mechanisms, if I'm not mistaken. So there's all sorts of fun, like, you can argue they're bells and whistles until you need them. and like one thing I have always found is like every item that I see here, you might not need it right now, but for every item you see, you do plausibly go, oh, but that might be useful later down the line somewhere. Like the transaction thing where you retrieve 2 things at the same time. I don't really have a use case for it, but I can imagine. But I can imagine that one might, where the consistency really matters.
Yeah, I can. I could see using the fan out cache.
Yeah, definitely.
But probably not the transaction. But I'm already talking to MongoDB, which doesn't have transactions effectively, so not really. What about performance? Should we talk about your graphs? You brought pictures.
Yes, so that might be. So when you told me like, "Hey, Vincent, let's do an episode on Discash," and I kind of told myself, like, "Okay, then I need to do some homework and like actually have to use it for something real. It's a bit complex." So what we're going to try and do is we're looking at a chart right now, and I'm going to explain to Michael what it does, and I'm going to try to explain it in such a way such that if you're not watching but listening, that you're also going to be fairly interested in what you're seeing.
And I'll link to the chart, of course. People can.
Yeah, so this is all running on GitHub pages, and the charts that you see here definitely needed a bit of DiskCache to make it less painful. So what I've done is I've downloaded a Git repository. What you're looking at right now is the Git repository for Marimo. And then I just take a point in time, and I say, okay, let's just see all the lines of code. And then I take another point in time, and then I basically just do kind of a git blame to see if the line got changed in between. So what you're looking at here is kind of a chart over time where it's basically like a bar chart, but it changes colors as time moves forward. And the shape that you see is that things that happened early on, well, there's a nice thick slab, but it gets a little bit thinner and thinner as time moves forward because some of those lines of code got replaced. But in the case of Marimo, you can see that most of the lines of code actually stay around for a long time, and it's kind of like a smooth sedimentary layer every time we move forward.
It's compressing a little over time. Like there's the weight of the project has sort of compressed it. So yeah, it's pretty interesting.
So that's pretty cool. But you can also go to Django. So there's a selector on top.
If I go to Django. Oh, you even put Discash in it.
Yeah.
Oh, this is really different.
Yes. So
what is this telling us?
So what you can see here is that at some point in time there's a huge shift in the sediment. There's a lot of light sand, and a lot of the dark sand goes away. There's also a button that allows you to show the version number. So Yep, there you go.
There we go. Yeah.
So you can see that right before a new version, a bunch of changes got introduced, or like right after. And it's usually like around the version number that you can see that shift.
Right. Once the feature freeze is lifted, some stuff comes in, PRs come in maybe or something.
Yes, and
Okay.
one other thing that's actually kind of fun, if you go, there's this project called Scikit Lego that you can also go ahead and select. And folks,
I've heard a pretty cool guy maintains that. Yeah.
well, so the funny thing is, you can see that there's a massive shift there at some point.
Okay.
That's when we got the new maintainer.
Are you on the purple or the green side?
So, so there's this dark blue sediment that sort of goes down massively at that point. But yeah, no. So, but in this case, like the first thing he did is redid all the docs. So we went from Sphinx to Make docs, and that's like a huge. If you look at the lines of code that changed as a result, that's quite a lot.
Yeah.
But if we now start talking about how you make a chart like this, you got to imagine, like, I take the start of the GitHub history, I take the end of the GitHub history, I sample like 100 points in between, and then for every line in every file, I do a git blame.
I think Django is something like 300,000 lines of code. I mean, that's a lot of
Yeah. So that thing took 2 hours and 15 minutes on my M4 Mac, and if you go there, you can actually select it. That was a chunky boy, is what I'll say.
Yeah, 550,000 lines. Yeah.
There you go. But you can see that there's one version change, I think, where they made like a bunch of changes, and it could be that that might have been again, like, because I checked the docs as well on Markdown files. It might have been like a big docs change, but hopefully by just looking at this, you can kind of go like, oh yeah, this is probably a notebook somewhere, and there's like a huge like for loop that does threading and like tries to do as much in parallel as possible, and there's a progress bar. Right.
Yeah.
And we don't want
now I see why you had this problem with the caching.
That's right. So but yeah, but here's also where the threading kind of came in, because the moment you say this point in time, now do all the files, do the git blame, that's definitely something that can happen in parallel. But then for every file, for every point in time, you do want to have something in the cache that says, okay, if I have to restart this notebook for whatever reason, that number is just known. Don't check it again.
Yeah. Yeah, super interesting. Okay. I wonder if this 4.0 in 2022, is that might be when they switched to async. They started supporting async. But it could be docs as well. I'm not sure.
Well, yeah, so that's kind of the hard thing with some of these charts. Like, I could expand these charts by saying things like, okay, only the Python files, etc. But like the way that this is hosted, this is like really using the disk as a cache, because all these charts are Altair charts, and you can just save them to disk, and then you can easily upload them to GitHub pages. So I do everything in Discash to make sure that if for whatever reason, the notebook fails, I don't have to sort of do anything fancy to get it back up. But then once it's time to actually like put it on the site, I could use Discache to like show the charts, but then I would need a server. So actually using disk to actually just serve some files is also just a pretty fine and good idea. There are some things on the Marimo side where we are also hoping to maybe give better caching tools to the library itself. It's just that when I was doing this, I actually found a bug in our caching layer, so then I switched back to Discache.
You know what? Look, that's valuable. It's maybe not the way you would find, but it's valuable.
It's one thing you learn is that caching is actually hard to get right.
It is. It is. It's very hard.
It's like on par with like naming things.
It is one of the two things that goes wrong: naming things, cache invalidation, and off by one errors.
Yes, exactly.
Right? It's the middle one.
Yeah. The dad jokes are amazing. Anyway, no. So one thing about this repo, by the way, this is all my we're going to add a link to the show notes. There is a notebook, so if you feel like adding your own project that you want to just add, feel free to spend your compute resources 2.5 hours to add a popular project. I would love to have that. One thing I think will be cool with these sorts of charts is to see like what would change when LLMs kind of get into the mix. Like, do we see more code shifts happen if more LLMs get used for these libraries?
Very interesting. I don't know if more old code will get changed, but they are verbose code writers, those things.
Yes. Well, so this, assuming we can like do this over time, and we're going to start tracking this, I'm calling this code archaeology. I do think it'll be an interesting chart. Like as is, I think it's already quite interesting to see differences between different projects. I think if you go to sentence transformers, you can also see when the project got moved from like an academic lab to Hugging Face. So there are like interesting things you can see with these charts, but you are going through every file, every line, git blame 100 times.
Yeah, a lot. Oh, 100. You got to do 100 times per line as well.
Well, so the start of the project of the Git repository, and then to make a chart like this, you got to sample over the entire timeline. And it is a bit cheeky because sometimes you can go like, okay, but there's like a character that changed because of a linter, and then like, is that really a change?
Yeah.
Does it really matter?
It's whoever decided to run, rough format on the thing or whatever.
Like we're looking at the Django chart. It could also just be that Black just got an update or something like that, right?
Yeah, exactly.
It's also possible.
It's very possible.
It's unlikely, but it's not impossible, let me say. But yeah, anyway. But yeah, this was one of the benchmarks that I did with DiskCache that I thought was like pretty amusing and pretty interesting. But there's this one other feature that I think we should also talk about, which is that if you want to, DiskCache actually lets you do the serialization yourself. So normally, what it would do is it would say like, okay, let's do the pickle thing, and it's a bit clever, right? So if the thing you're storing is like an integer, then it doesn't go through the whole pickle thing; it just stores it as an integer. There's these native types that SQLite has, and then it's able to do something clever. But
but as soon as it becomes like a custom class or a list of weird things, then it's. I personally don't like it pickling. I would prefer that it makes me do something. I think it's weird.
Well, so the thing is, you can write your own disk class, and then what you can do is you can pass set disk class onto the DiskCache itself. And I was just kind of wondering, like, when might it make sense to do this sort of a thing? And if you go to the docs, there's actually like a really good example just right there, which is JSON.
Yeah. Where did I lost your example. I'll get it back.
If you type disk, you'll find it. So JSON has this interesting thing. It is text, if you think about it, but it's text that has a bit of structure. And that means that there are these compression libraries you can actually run on them. And especially if you have like a pattern that repeats itself, let's say a list of users or something like that, and there's always the user key, and there's always maybe the email key, and those things just repeat themselves all over the place, then there is an opportunity to, there's this library called zlib, where you can just take that string, you can compress it, and then that compressed representation can go into DiskCache instead. And yeah, I figured like that sounds like a lot of fun. You can just grab the implementation there. So I have this notebooks repository where I have LLMs just write fun little notebooks. I always check the results, obviously, just to be clear on that. But one thing that was, I think, pretty cool to see, like if you just do the normal data type and you pickle it, then you get like a certain size. And if you were to like, if you just have a very short normal Python dictionary basic thing, then it's like negligible, like you shouldn't use this JSON trick. But the moment you get text heavy, like there's just like a lot of text that you're inputting there, and there's some repetition of characters, or like if you really do something that's highly compressible, it is not unheard of to get like 80-90% savings on your disk space, basically. Now, there is a little bit of overhead because you're doing the compression and sort of decompression. But if you're doing text-heavy stuff, this is something that can actually save you a whole bunch. And I can imagine for LLMs, this would also be like kind of a win.
Okay. So this JSON disk, not only does it serialize to and from JSON, which I think is safer. It can be a pain if you got date times, you got to do something. You got to
use OR JSON or something like that. You can.
Yeah. I think, but then it's using zlib here. I just actually did something like this for just something in my database. It had nothing to do with caching, but these records are holding like tons of text for something sort of tangential to the podcast. And I'm like, I don't really want to put 100K of text that I'm not going to query against or search into the database. So I used Python's XZ implementation, and like you said,
there's a bunch of compression algorithms you could.
It was way fast. So I just store it as bytes now, and it's like a tenth the size. It's great. Yeah. So I guess this is the same, but for the cache backend, right?
Yeah, and I think you can see I think zlib is being used internally.
Yeah. I mean, it's not XZ, but it's the same idea.
Yeah, it's exactly. So it's and there's always new compression algorithms. Like, feel free to check whatever makes sense. But the fact that you have like one very cool example to add on the docs, because you can just copy and paste it, a lot of people benefit from it. But why stop here? Because this is something you can do for JSON. What else can you do?
Before we move on, though, I would if I were writing this, I would recommend using like OJSON, micro JSON or OR JSON or whatever some of the more high performance versions right there. What do you
Yeah,
think?
and I think ORJSON. I mean, performance is cool. The reason I use ORJSON a lot more has to do with the types that it supports. So it can
I
accept
see.
NumPy arrays, for example, and just
Oh,
listifies it. And I
yeah.
think it has
There you
like
go.
there's a few things with dates as well, and it just has a slightly better support for a few things.
Okay, good to know. All right, where are we going? What's next?
NumPy arrays.
Okay.
So a lot of people like to do things with embeddings nowadays. So like text thing goes in, some sort of array thing comes out, and then hopefully if two texts are similar, then the arrays are also similar. So you can do all sorts of fun little lookups. And I do a fair share of like doing things with embeddings, and embeddings are also like not notoriously expensive to calculate, but still pretty expensive to calculate. Okay, but you can write your full Python thing in there. So if you compare like storing NumPy as bytes compared to that to a pickle, it's actually like even. There's like very little to gain there. But one thing you could do is you could say, well, let's maybe bring it down to float 16. That's a thing you can do. You can sort of say before we save it, we actually make it just a little bit less accurate on the numeric part of it, but that'll save us a whole bunch of disk space. So that's already kind
Right.
of home.
Well, you need it to be super precise when it's involved in calculations. But then in the end, if you're not going to report the numbers to great decimal places, maybe going down is good. Yeah.
Yeah, it depends on the use case, but typically, like you could argue, maybe a 1% difference in similarity. If we have 100x like savings on disk, like that'll be kind of a win. So one thing I was sort of focusing on is just this. You can do things like, okay, come up with your own little weird data structure where you say like, okay, let's pretend we're going to quantize the whole thing. So we're going to calculate the quantiles of the float values that it can take. And we're going to take like the basically 256 buckets. We're going to store the scale. We're going to store the mean. And then we're going to store in what bucket the number was in. And you can turn that into a string representation. These things are pretty fun to write.
Nice. Okay.
And yeah, and then you scroll down in your big notebook and then you find this. There you go. That's a retrieval time. I think I got like a 4x improvement in terms of like disk space being saved. It was like a 1% similarity score that I had to give up for doing things like this. Mileage can vary, of course, but like,
yeah, sure.
Again, these are fun things to sort of start playing with because you have access to the way that you write that down. So that was also like a fun little exercise to do.
Yeah. Could you save NumPy arrays by just just converting it to bytes? There's probably some efficient.
Well, yeah.
Or
So
you could, you know what about a Parquet file? Like in an in-memory Parquet file, then you just say, here's the value in bytes.
So I tried the bytes thing and compared it to the pickle thing, and that was basically the same size.
Okay.
So that barely led to anything. About the Parquet one, I mean,
you do get compression.
Well, yeah, but I could be wrong on this one, but I think Parquet is optimized to be a disk representation, and then once you want to have it in memory, it becomes an arrow representation.
I see. Yeah, probably.
So in that sense, what I would do is, okay, if you have something in arrow, you use DiskCache to make sure it's written as Parquet. But then you kind of have to know what you're doing if you're going to make Parquet files. And also the benefit of a Parquet file is that you have like one huge table, because then
right, you can scan it. Yeah.
Yeah, it's a columnar format. So then, if I were a column, boy, would I want to have all the rows in me.
Yeah.
So in that sense, so in that sense, what I would do instead is if for whatever reason you just have a lot of data, it's still kind of a cache, but it makes more sense to store all of it in like a huge Parquet file. In Parquet, you can store partitions, so you can say this one column that's partitioned. A date would be like a very typical thing to partition on, and then if you point polars to like Parquet, but you say I only want to have this date, it can sort of do the forward scan and only pick the rows that you're interested in.
I see.
I would imagine that would like beat anything we might do with DiskCache, especially if the table is big.
So you don't always want to cache stuff. Like I said, I actually don't avoid hitting the Mongo database a lot for my projects because it's like the response time is quick enough and like might as well. So I want to take two little avenues here, but the first one is, what about DuckDB? I know at least on the data science side and the analytics side, like DuckDB is really popular, really well respected, really fast. Maybe you don't even cache it. Maybe you just use DuckDB as a thing. How do you feel about that?
I mean, DuckDB does solve like a very different problem than SQLite or Postgres in a way. So like, I don't believe, to name one thing, I believe DuckDB does assume that everything under the hood is immutable. So it will never be ACID compliant because it doesn't necessarily have to be. You can still insert rows if I'm not mistaken, but the use case is just assumed to be analytical in general. That like,
I see.
it's really designed to sort of fit that use case. You can insert rows though, so like that's
I
something
mean, you
people
might
need to
be
consider.
caching data science things that you're only computing once, like your, for example, your charts. I mean, once you've computed that, it's not going to change because it's historical.
I mean, I might want to rerun it a month later or something like that. Like that's something I might want to do. And
Yeah.
in that particular case, it would be cool if the sampling is the same and I just want to add one sample at the end, that all those samples I had before, that those are like in a
Right.
cache somewhere.
Or maybe you want faster, like better resolution. Instead of going 100, you're going to go to 1,000 points, but you could do 10% less
Yeah.
because those are done, right?
So stuff like that. But then what you would never do with a cache is do like a group by and then a mean, for example. It's like
It's not. It's outgrown its use at that point. That's for sure.
yeah, like, and if it were a part of it, like, then the docs would say so. But like, no. So like in my mind, like DuckDB really just solves a different problem, similar to like general SQLite also solves a different problem than Discash, and also Postgres is also solving a slightly different problem.
Sure. All right. Fair.
Like
The other angle.
yeah.
Go ahead. Finish your thought.
Well, I also really love Postgres. I gotta say, like the thing I really like about it is that it is like boring, but in a good way, software where like I have a Postgres thing running there, and whatever SSH thing I need, I can just swap the cloud provider, and it'll just go ahead and still run without me having to move the data or do any migration or anything like that. That is also just like a nice feeling, but it solves a different problem.
Yeah. These would very likely be used together, not instead of. I mean, Postgres could be used instead of Discache, but Discache definitely not instead of Postgres. Yeah. So the other angle I wanted to have you riff on just a little bit is, I think people, especially people who are maybe new to this idea of caching, they can end up thinking, okay, I'm going to store stuff. We talked a lot about like, I get something back from the database. I could store that in a cache so I don't have to query it again or whatever. And those are certainly good use cases. But I think a lot of times an even better use case is, if you're going to get 20 rows back from a database, do some Python and construct them along with a little other information into some object. And then that's really what you want to work with. Store that constructed thing in the cache. You know what I mean? Like as far as you can go down the compute layer, like don't just stop like, well, it comes back from the database, so we cache it. Like if there's a way to say, like there's a bunch of work after that, think about how you might cache at that level.
Okay, I'm gonna pitch you a dream then.
Do it.
Imagine you have a Python notebook, and you're running a cell, and halfway the kernel dies for whatever weird reason.
Right.
It'd be nice if I could just reboot the notebook and it would just pick it up again and move further. Because again, I'm picking something out of a database, and I'm doing something little with it, and processing. But wouldn't it be nice if maybe every cell had like a caching mechanism?
If you had some influence
if
over a company that did this kind of stuff.
Yeah. But you can imagine these are things that we are thinking about, and like if and again, what I'm about to suggest is definitely a dream. This is not something that works right now. Don't pin me on this. Like we're thinking out loud here. You can also imagine this being super useful, where an entire team can share the cache.
Yeah.
Right, so that if your colleague already calculated something, that you don't have to recalculate it again. Like there's all sorts of use cases like that as well. But then maybe there are these moments when you want to have very tight manual control over what goes into the cache. That makes a lot of sense and it's great. But there are also moments when you just really don't want to think about it at all, and you just want everything to be cached.
Could I just use this thing as a checkpoint, like an autosave, sort of as my code runs? Yeah, that's cool.
Yeah. So and again, like doing this right is hard because there's all sorts of weird Python types, and I mentioned the progress bar thing, and there's all sorts of things that we got to be mindful of here. But as if you're thinking about like really like how would you use this in data science when you fetch a little bit of data and deal with it, to me it is starting to feel more natural to then think about like cells in a notebook and maybe cache on that level.
Yeah, that's pretty interesting, and just sort of cascade them along as a hash of the hashes of the prior cells, or
and this is where things become tricky, of course, because then I've got this one cell and I change one function in it. If you're going to cache on the entire cell, everything has to rerun, and then if you're not careful, your cache is going to be huge. So like, how do you do this in a user-friendly way. There's all sorts of like it sounds easier than it is the one thing I want to say.
Yeah. Well, I think you got a better chance with Marimo than with Jupyter, at least because you have a dependency graph. So
Yeah,
you can at least say like, if this one is invalid, that means the following 3 are also invalid. You know,
Yeah.
like you can sort of propagate it there.
Totally. And but it's like I try to focus a little bit more on the user experience side of things. And one thing I've really learned from the notebook with like the progress bar is just there were moments when I felt like, oh, I just want this entire thing to be automated. Don't make me think about this.
Yeah.
And then there were moments where I thought, oh, it's really nice to have tight manual control. How do I provide you with both?
Yeah.
That's quite tricky. But it is a dream. So that's something to keep in mind.
Yeah. Maybe someday there'll be a turn on cache flow checkbox. Something.
Or well, and at least till then, I do think having something that works on disk instead of memory these days is also just a boon.
Right. So this works in data science notebooks. It works in web apps. It works in little TUIs. Right. It doesn't care.
It works with LLMs, and like if you have a kind of actually similar to your setup, like if you have multiple processes with your web app running on one VM, if you have one big VM that you share with your colleagues, you can also just share the cache actually.
Yeah, that's true.
There's
no reason
actually,
you can't just point to the same file. Yeah.
Yeah, and especially if you're doing like big experiments like grid search results or stuff like that, that you really don't want to recalculate the big compute thing. That's actually not too unreasonable.
Yeah, that's cool. If you have a shared Jupyter server. Boom.
Yeah, and a bunch of universities have that, right? So it's,
exactly.
Yeah.
I don't want to go down this path because we're basically out of time, and I want to respect your time. However, I do think there's a whole interesting conversation to be had about like how do you choose the right key for what goes into the cache, because you can end up with staleness really easy if something changes, but if you incorporate the right stuff, you might never run into stale data problems because, like for example, I talked about the YouTube ID. Basically, the cache key is something like episode data, episode YouTube thing, YouTube, the hash of the show notes, right? Something like that, where there's no way that the show notes are going to change and I'll get the old data because, well, guess what?
Yeah.
It's constructed out of the source, right? Things like that. There's probably a lot, especially like in your notebook side, there's a lot to consider there, I think.
Yeah, I mean, so I remember this one thing with the course where I still wanted it to be cached, but I wanted to have like text goes in and then 5 responses from the LLM go out. And the way you solve that is you just add another key, but you have to be mindful of the cache key. And you can and you can use tuples, by the way. That's also something you can totally use as a cache key.
Right.
Discash. So that was easy to fix. It's just that you have to be mindful.
That's kind of, I want to give a quick shout out to that. I want to leave. I don't want to leave on a sour note, but I think it's necessary to give this shout out, or this call this out rather is the way I should say it. I think this project is awesome. You think it's awesome. Honestly, I think it doesn't need really very much, but if you look at the last updated date, it hasn't got a lot of attention in the last 6 months or something like that.
Yeah, and if I look at PyPI, the last release was 2023, which, a year and a half ago.
Yeah, and it's okay to I would like to say that it's okay for things to be done. Things don't have to change, but there's also a decent amount of conversations on the issues, and they haven't, like a couple days ago, actually, someone asked about this, but the last changes. I believe the guy Grant who works on it started working at OpenAI about the time changes stopped going on. So I'm not entirely sure. I feel like I could be confused that with another project. So Grant, if that's not true, I apologize. But I think that it is. Pretty sure that is. So we have LinkedIn. Surely we have LinkedIn here.
I am comfortable stating let me put it this way. Yes, my colleague might make a different caching mechanism, and yes, I might use that at some point, but at least for where I'm at right now, Discash needs to break vividly in front of my face for me to consider not using it. Because it does feel like it's done, and in a really good way. Like the main thing that needs to happen, I think, functionally, to make sure this doesn't get deprecated too badly. It's just you got to update the Python version. When a new Python version comes out, you got to update PyPI to confirm, like, okay, we do support this Python version.
Yeah.
But I mean, most of the, like, if you look at the area that needs to be covered, a lot of that has been covered by SQLite, and that thing is definitely still being maintained.
Yeah, it's getting mega maintained. That's right. So I also don't see the problem. I'm not going to not use it.
Yeah.
I just want to put it out there on the radar for people for whom might go look at go, oh, Michael and Vincent were so psyched, and I started to use this, and now I'm really disappointed because of, whatever, I saw this.
I mean,
so
the only real doom scenario I can come up with is if SQLite made like a breaking change. That's the only thing I can kind of come up with. But the odds of that seem very low.
Yeah, and it's on GitHub. You can fork it. I forked it.
Exactly.
So, no, I definitely am still super excited about it. I just want to make sure that we put that out there. I'd intended to talk about it sooner, but in the conversation. But you know what? We were just so excited.
Yeah, no, it's this is definitely in my top 5 favorite Python libraries outside of the standard lib.
Awesome. Yeah, I really, really have gotten awesome results out of it as well. So remember the way we opened the show, and you talked about this, like when we talked about the LLM building block stuff on the previous time you were on the show, it's like, oh, we better not go too deep on this, even though we're both so excited because it's going to derail the show. We're now 1 hour and 15 minutes into it. We got to kind of cut ourselves off. I think we think that was accurate.
It's I mean, you get 2 dads making dad jokes and riffing on tools they both like. It's bound to bound to exceed a barbecue.
Yes, I know. I wonder what would happen if sometime we just removed the time limit and just got real comfortable and just riffed on something. It could be hours. It would be fun, but maybe not.
2-hour live streams exist, Michael.
I know. I've listened to some podcasts at over 3 hours. I'm like, how's this still going? But you know what?
It's all
good.
But this is a good point in time to put. We're both excited. That's the summary.
That is the summary, and I think I'm going to let you have the final word on this topic here. Like, maybe speak to people just about caching in general and Discache in particular as we close it out.
I mean, I guess the main thing that I learned with the whole caching thing the last couple of years, I always thought it was kind of like a web thing. Like, front page of Reddit, that thing has to be cached. That's the way you think about it.
Yeah.
And thinking about it too much that way totally blocked me from considering, like, oh, but if you do stuff in notebooks and data science land, then you need this as well. And I think there's actually like a little like emerging discovery phenomenon happening where like people that do things with LLMs, they at some point go like, oh, I need a cache. And then,
yeah.
That's the main thing I suppose I want to say. Like, even if you're doing more data stuff, like give this Discache thing a try. It's just good software.
Yeah, it's so easy to adopt and try out. Like, you can throw it in there.
Just add a decorator.
See what you exactly. See what you get. See what you get. All right, Vincent, welcome. Oh, thank you for coming back. I really appreciate it.
Thanks for having me again.
Always good to talk to you. Yeah.
And see you next time when we again find out there's a cool Python library.
Yeah, that's gonna be the 3 hour episode. Watch out, y'all.
Yeah. Have a good one.
All right, later.